A series of leaks leaves 4 astronauts stranded on Earth. SpaceX begins making way for a new Starship launch site in Florida. ESA celebrates its 50th anniversary, and Blue Origin shows off progress on its crewed lunar lander. All that and more coming up this week in Spaceflight. A series of leaks on Earth and in space has stranded 4 astronauts on Earth. Now don't worry, they're fine, but they were supposed to go up to space and now their ride-up is postponed indefinitely. So in a way, they're kinda stranded, aren't they? So what happened this week? Well, Axiom Space, SpaceX, and NASA had all been gearing up for the launch of the Axiom 4 mission. 4 astronauts would launch to the International Space Station for a 2-week stay to carry out nearly 60 scientific studies focusing on human health, plant and microbial biology, the effects of microgravity, and technology demonstrations. This 4th private mission to visit the ISS will carry a very international crew led by Commander and former NASA astronaut Peggy Whitson. Joining her are pilot Shubhanshu Shukla from India and mission specialist Sławosz Uznański-Wiśniewski from Poland and Tibor Kapu from Hungary. The 3 first-time flyers will mark the return to space for their nation since the early 80s and even earlier for Poland. On June 8th, SpaceX fired up the booster for this mission, B-1094, for a static fire test. Unfortunately, the test uncovered 2 main issues. There was a liquid oxygen leak in the booster's engine bay and also a thrust vector control issue on one of the 9 Merlin engines. Now, weirdly enough, the liquid oxygen leak didn't really come as a surprise to SpaceX. In fact, the company had discovered the issue on the booster's previous mission, which had also been its first. After successfully delivering 23 Starlink satellites to space, it sprang a leak during re-entry back through Earth's atmosphere. They had planned to repair the leak while refurbishing the booster, but they couldn't find it, so it snuck through. They didn't seem all too worried, though, as this time SpaceX was able to fix it and even performed a wet dress rehearsal on June 12th to confirm that the booster was now leak-free. Additionally, SpaceX added a purge to Falcon 9's pre-flight plan to mitigate the leak if it somehow persisted. So what about the thrust vector control issue? Well, if you remember, thrust vector control is the mechanism that moves around the engines to change the direction of thrust, the thrust vector, to steer the rocket. But the issue was easily fixed. SpaceX replaced some faulty components to get the rocket ready for flight. Now, in many ways, the process worked as intended. The test revealed issues, and SpaceX was able to fix them. SpaceX's Bill Gerstenmaier explained.
Again, I think this shows the difficulty of getting ready. You can always be prepared, but doing the testing, doing the dry runs, doing the activities with the crew to make sure we are really ready is tremendously important because we always learn something.
But just when we thought the issues with the launch vehicle were resolved, the mission was delayed again, this time by NASA. Remember that I said that there was also a leak in space? Well, it turns out the ISS isn't ready for visitors just yet. NASA and Roscosmos are dealing with leaks on the station's Zvezda module, which is slowly losing pressure. It's not ideal, but this isn't anything new. The cosmonauts aboard the station have been chasing the issue for years, trying to fix it, but recently the leak rates changed, prompting some new investigations. The cosmonauts on board the ISS have already performed inspections of Zvezda's interior surfaces and sealed off some of the areas of interest. For now, this appears to have stopped the leak, but it also halted the launch of Axiom 4. Why? Well, NASA decided to postpone the launch to allow some extra time to evaluate the situation and to do some additional troubleshooting. You really don't want to welcome 4 visitors to your space station if you don't know that it's holding in the air that they're supposed to breathe. So, taking time to make sure that the leak rates are manageable seems like a safe decision. Hopefully, the cosmonauts will get the leaks under control soon so Axiom 4 can get up there before too long. With any luck, the crew won't have to wait too much longer, and when the time comes, they'll be more than ready to fly. Relativity Space continues to build momentum as it pushes forward towards the first flight of its reusable Terran R rocket. Now, even though it has yet to fly one successful mission, Relativity is already preparing for high-volume production of the vehicle. The company is now well into engine qualification testing of its 3D-printed Eon-R engine at NASA's Stennis Space Center in Mississippi. The Eon-R burns liquid methane and liquid oxygen, 13 of which will power Terran R's reusable first stage. 11 hot-fire tests were recorded in May, including 4 lights of the engine in less than 10 hours, and the company plans to continue engine qualification testing through this summer. The company also continues to ramp up rocket production at its Long Beach facility as it lays the foundation for scalability and manufacturing efficiency. With critical design reviews now completed for many of the less complex parts of Terran R, Relativity can ramp up assembly. Over in the second stage department, teams are making key steps towards completion of the second stage tank, with the liquid oxygen dome now ready for its next weld and transfer tube welding already underway. Meanwhile, Relativity is installing more machinery on the factory floor to streamline the manufacturing process. A vertical turning lathe is ready for multi-axis machining of tank domes, and a new horizontal friction stir welder was installed for welding first stage stringers. These welds are verified using phased array ultrasonic testing, and to speed up this process, the company is constructing a second system to automate stringer inspections. To further speed up production, Relativity automated drilling of thousands of holes across various thrust structure panels. Taking a look outside, Relativity has installed strut assemblies onto the structural test stand. These will simulate engine loads during testing, and it won't be long before we see them put through their paces with full load testing. Relativity has been gearing up to manufacture at scale since before it started producing Terran R flight hardware in March. Robin Petitpré has now joined the company as Senior Vice President of its manufacturing and supply chain after previously holding a similar position at SpaceX. He's expected to help Relativity advance towards industrialization. But if the company wants any chance at launching any rockets, it needs a launch pad. Relativity has been building one at Launch Complex 16 at the Cape Canaveral Space Force Station in Florida, and they're busy refurbishing the pad and infrastructure to get it ready for Terran R. The east wall of the flame diverter pit is now complete, and foundations are underway for the water tower. Meanwhile, the horizontal integration facility has really taken shape over the past month. It's now been over 2 years since Relativity's 3D printed Terran 1 took its debut flight from this pad, dubbed Good Luck Have Fun, but it failed to reach orbit. The mission was the first and only orbital launch attempt from LC-16, which previously hosted tests of Titan missiles in the 60s, some of which even fed into the development of the Titan II as a human-rated launch vehicle for NASA's Gemini missions. The pad was deactivated in 1988 and remained dormant for 30 years until Relativity signed a 5-year agreement with the U.S. Air Force in 2019 to occupy and operate at the site. It's now moved into the optional extension period, which runs to the late 2030s. If successful, Terran R's maiden launch next year would become the first orbital launch from LC-16, and we are definitely here for it. The European Space Agency recently turned 50, and it celebrated the occasion by blasting music into space. Yes, really. ESA arranged a live performance of the Blue Danube, which is famously the soundtrack for docking spacecraft in 2001: A Space Odyssey. The waltz was performed in Vienna by the Wiener Symphoniker and live-streamed across the world, as well as transmitted into space using its Cebreros deep space antenna in Spain. The signal was aimed at NASA's Voyager 1 probe, the spacecraft farthest from Earth, and the transmission is currently traveling through the universe at the speed of light, celebrating the birth of a space agency 50 years ago. 10 nations came together to form the agency back on May 30th in 1975. That's when the European Space Research Organization merged with the European Launcher Development Organization to form ESA, lighting the spark for half a century of space exploration and scientific achievement. Since then, the agency has grown to 22 member nations and a few non-full members, including Canada. Actually being located in Europe is clearly not one of the requirements. Together, these countries have made history with a number of groundbreaking missions. For instance, the Rosetta spacecraft caught the world's imagination in 2014 by chasing a comet across the solar system and then landing on it. This was the first time that a craft had orbited, landed on, and returned images from a comet. ESA also landed the Huygens probe on Saturn's moon Titan and sent the JUICE Explorer to study Jupiter and 3 of its moons. Strong in astronomy, ESA sent its own Gaia Space Observatory to the Earth-Sun Lagrange Point 2, where it's been charting over 2 billion stars ever since, building the most detailed 3D map of our galaxy, the Milky Way. Gaia recently retired, but its data is still being released to the global science community, sparking even more discoveries, including one that we discovered last week. Additionally, the agency provided instruments and solar arrays for the Hubble Space Telescope, and it also contributed 2 of the 4 main scientific instruments on the James Webb Space Telescope, which it launched on board the European Ariane 5 rocket back in 2021. Most recently, in 2023, ESA launched its Euclid Space Telescope. Euclid will map over a third of the sky, cataloging billions of galaxies, and will help to unravel the mysteries of dark matter and dark energy. But it's not just science. The agency is also a key partner in NASA's Artemis program, contributing the European Service Module for Orion missions back to the moon. Moreover, it's a core partner in building habitation and other infrastructure for NASA's Lunar Gateway project, which unfortunately is now at risk with the proposed NASA budget reductions, as you also may have seen on last week's episode. The agency has had had its share of delays, both with its Ariane 6 carrier and the Rosalind Franklin ExoMars rover, which has been reevaluated since the invasion of Ukraine to use non-Russian hardware. The rover is already built and in storage, while the new landing system is currently being developed, and it's targeting a launch in 2028. With projects like this and many more on the horizon, we're excited to see what ESA delivers in its next 50 years. Now we'll take a look at some other stories across space, starting with our first ever close-up look at the Sun's South Pole. It's an area that we never really get a chance to see. Here on Earth, our view is directly towards the Sun's equator, and all spacecraft designed to observe the Sun are orbiting in the same plane. All except for one, the European Space Agency's Solar Orbiter mission. On February 18th, this spacecraft flew by Venus, an encounter that changed its trajectory to dip 17 degrees above and below the equator. This allowed Solar Orbiter to peak at the Sun's South Pole roughly a month after its Venus flyby, and this week we finally got to see the images that the spacecraft took of that view. It also got some similar views of the North Pole in late April, but we likely won't get those images until October when Solar Orbiter is closer to our planet. While viewing the South Pole, it studied it with its suite of instruments, taking images in visible light and ultraviolet, and using its spectrograph instrument, which allowed it to track how fast material is moving around. It also mapped the Sun's magnetic field. That one is of particular interest to scientists, as it flips once during each 11-year solar cycle. The magnetic field is most stable and orderly at a solar minimum, but we are currently around a solar maximum, so it's no surprise that Solar Orbiter found a very, very messy magnetic field. Our view of the Sun's poles will get even better over the next few years, when even more flybys of Venus are scheduled. Each of these will increase the tilt of the spacecraft's orbit more and more, up to 33 degrees in 2029. Then we'll get a front row seat as the Sun calms down over the next few years. Just as Solar Orbiter was getting its first views of the solar poles, NASA launched another mission to study the Sun from orbit around Earth. The Polarimeter to Unify the Corona and Heliosphere, or PUNCH to its friends, launched on a Falcon 9 on March 12th. This week, NASA showed off the mission's first video of so-called coronal mass ejections, or CMEs. During these events, material erupts from the Sun, and in the new images, we can see it traveling through the inner solar system. Later in the video, the eruption arrives at Earth and shows up as parts of the image getting brighter as the radiation hits the cameras. Now, you may have noticed that these images are a bit patchy, and that's because PUNCH actually consists of 4 satellites that observe the Sun in unison. Together, they create a much wider field of view than the satellites would on their own. The satellites are still moving around in their orbits to align themselves perfectly, and once that's complete, NASA will be able to observe the solar wind in 3D. Scientists will then use this data to better understand solar wind, which sometimes causes problems with satellites, and in extreme cases even disrupts communications and electrical systems down here on Earth. And now we go from the Sun to the Moon. Blue Origin is working on a crude version of its Blue Moon lander for NASA's Artemis program. As of recording, it's planned to launch for the first time on the Artemis 5 mission, but with the current administration mixing things up, we'll still have to see if those plans hold. And really, anything could happen. This week, Blue released a video of a mock-up for this lander undergoing testing in NASA's Neutral Buoyancy Lab. Now, this is a giant pool in which astronauts usually test spacewalks, but for the Blue Moon test, they simulated lunar gravity, which is 1/6 of what we're used to here on Earth. They also added some lights to mimic the lighting conditions on the lunar South Pole. The mock-up has the exact dimensions of the lander's airlock hatch, as well as its height off of the lunar surface. 2 people wearing spacesuits demonstrated exiting and entering the lander the same way that it should be done during a moonwalk, and also tested cargo transfer and emergency procedures. Great work, Blue. They may be practicing in water, but soon they'll be making waves on the moon. And in other moon mission-related news, Astrolab showed off its FLIP rover, or actually a test version of the rover that will only drive around on Earth. The company's working on FLIP as a testbed for its much larger Flex rover, which might even be the ride of choice for future astronauts. FLIP will launch on Astrobotic's Griffin lander later this year, taking the place of NASA's canceled rover called Viper. We covered the whole saga of Viper over previous episodes, and while it's been a bit of a mess, now FLIP gets to take its place. But before FLIP heads to the moon, Astrolab first wants to verify that everything works as intended, and that's where this week's vehicle comes in. It's not an exact copy of the rover that'll be sent to the moon, as it lacks solar panels and batteries, but it should be good enough to at least get the kinks out. Astrolab also shared a video of the vehicle rolling around in the test facility for the first time too. That's one small drive for a rover, but seemingly a giant leap for Astrolab. ESA is building a new telescope to detect potentially dangerous asteroids. While there are currently no dangerous asteroids predicted to hit Earth within the next 100 years, there are still many undiscovered. Space agencies around the world are now peering out at the skies to look for these potential threats so that we hopefully know what's coming well ahead of time. ESA's latest effort is to build a telescope called FlyEye. It's named for the way that its optical systems split light and analyze it with separate detectors. A fly's eye sees the world in the same way, so it's actually a really fitting name. And it's ready to catch anything that's buzzing through the solar system, right? The first of these telescopes is nearing completion and recently spotted its very first asteroid during a test at the factory in southern Italy. What's more, it also took a picture of the Andromeda galaxy to show off its wide field of view, but it only actually used 1/16 of its full field of view to image our neighboring galaxy. To see the same galaxy, the venerable Hubble Space Telescope had to stitch together 600 images. FlyEye's extremely wide view will help to spot hazardous asteroids much more quickly than before. Soon, the telescope will leave the factory for installation in Sicily. Ultimately, ESA wants up to 4 of these and has already started development on the next one, which will be installed in the southern hemisphere. We covered Stoke Space in last week's episode, and this week we're talking about them again because, well, they've been crushing it. Literally, the company released a video of a rocket part being crushed in a test. A barrel section for a tank on the first stage of Stoke's forthcoming rocket called Nova. In the test, the stainless steel tank section was tested to failure to see if it failed in the way that Stoke's analysis had predicted. Later in the week, Stoke also released an update on Nova's most striking feature, its upper stage engine called Andromeda. The rocket is supposed to be fully reusable, and Stoke is one of the very few companies that's working on a reusable upper stage. To survive re-entry after its mission, the hydrogen-powered Andromeda engine doubles up as a heat shield. And yes, that's really one engine with 24 thrusters, and they're all connected by a steel heat shield that's cooled with liquid hydrogen. This same process, called regenerative cooling, is commonly used to prevent engine nozzles from melting, so it should also hold up to the heat of re-entry. This week, the company announced that it's finalized the design for the thrusters that make up Andromeda. It took over 43 iterations and more than 53,000 seconds of hot fire testing since 2020, but finally, Stoke has landed on a flight-ready design. With a milestone like that, it looks like Stoke's future is heating up fast. Timber! This week on June 12th, the major legacy structures at Space Launch Complex 37 in Florida were taken down in a controlled demolition. This includes the mobile service tower and fixed umbilical tower used by the Delta IV medium and Delta IV heavy rockets. The demolition work that took place this week is part of preparations to build a Starship launch complex within Slick 37. Last week, the Department of the Air Force released the draft environmental impact statement for Starship launches from that site, unveiling all kinds of details about the plans that SpaceX has for the site. From having 2 launch pads up to 2 catch towers, 76 launches per year, and even a dedicated methane purification plant, the 176-page draft, plus an additional 964 pages of appendices, give all sorts of details about the expected operations and their environmental impacts. We went over it here at NSF on our last Starbase Update episode, and if you're more of a fan of the written word, our writer Alex also wrote an article summarizing it for our news site. While SpaceX is still not authorized to begin construction at Slick 37, the company has had a limited right of entry since February that's allowed them to prepare the site for demolition and clearing, something that we're already seeing underway and is expected to continue through the summer. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. Starting off the week, we had the launch of a Falcon 9 from Florida on June 7th at 4:54 UTC. The rocket was carrying the SXM-10 satellite for satellite radio company SiriusXM into a geosynchronous transfer orbit. This satellite adds on to the existing fleet of broadcasting satellites by SiriusXM and was the 4th launched on a Falcon 9 rocket. In a departure from usual missions by Falcon 9 to geosynchronous transfer orbits, or GTOs, this one included a deorbit burn of the second stage after satellite deployment for a targeted re-entry and disposal over the Pacific Ocean. On past Falcon 9 missions to GTO, the rocket's second stage was left in the same transfer orbit as the payload due to the high energy of the orbit. But this mission in particular carried a rather heavy satellite. The SXM-10 is believed to be roughly 6.4 metric tons in mass at launch, which means Falcon 9 can't quite put it all the way to a standard GTO, an orbit where the highest point is at the altitude of geostationary orbit, roughly 36,000 kilometers above Earth. Instead, the highest point of the deployment orbit was just under 22,000 kilometers. This meant that the Falcon 9 second stage ended up in an orbit that was just low enough that it could still be deorbited after deploying the satellite. And from a Falcon 9 from Florida, we now go to one from California, launching on June 8th at 1420 UTC. This one was carrying a batch of 26 Starlink V2 mini satellites into low Earth orbit. The first stage for this mission, B1088, was flying for a 7th time, and it successfully landed on SpaceX's drone ship Of Course I Still Love You. Bouncing back over to Florida, just a few days later, there was another Falcon 9 launch on June 10th at 1305 UTC. This one was also a Starlink mission, but carrying a mixed batch of Starlink V2 Mini and Starlink direct-to-cell satellites. As usual, the first stage for this mission was flight-proven, flying for a 12th time. It successfully returned to Earth, landing on the deck of Just Read the Instructions. And to take a quick pause from Falcon 9 rockets, we had the launch of an Electron on a mission called the Mountain God Guards. Liftoff took place on June 11th at 1531 UTC from Rocket Lab's own Launch Complex 1 in New Zealand. For this mission, Electron was carrying the QPS SAR-11 satellite into low Earth orbit. This was the 4th launch of a QPS SAR satellite by Rocket Lab for the Japanese Earth observation company IQPS. These satellites are part of a constellation that use large deployable X-band antennas to perform regular synthetic aperture radar imaging of the Earth. And we had even more launch activity squeezing in right at the end of the week with another Falcon 9 launch from Vandenberg carrying more Starlink V2 mini satellites. The first stage for this mission, B1081, was flying for a 15th time, becoming the 15th booster to reach this milestone. Kind of fun when you think about it, right? 15s. And the 5th and final Falcon 9 of the week happened not long after from the other coast of the United States, carrying another batch of Starlink V2 Mini and Starlink direct-to-cell satellites into orbit. The first stage for this mission, B1078, was flying for a 21st time and successfully landed on SpaceX's drone ship, a shortfall of Gravitas. Going into next week, we of course expect more Starlink launches. No surprise there. We're also hoping to see whether SpaceX can finally launch the Axiom 4 mission to the ISS. Next week, we also have an Atlas V by United Launch Alliance carrying the second batch of operational Kuiper satellites for Amazon. That launch is currently targeted for no earlier than June 16th at 1725 UTC, but we'll see if the Florida afternoon weather allows it to launch on time. Next week, we may also have a potential Angara in its most powerful configuration launching from Plesetsk in Russia, and there may also be a launch or two from China sneaking into the schedule as well. As usual, for real-time updates, check out nextspaceflight.com or download the app on your phone where you can get all kinds of launch alerts and even notifications about Starship testing. There may be some of that happening soon too. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.